Hi everyone, very good evening and welcome back to Geeks practice. Today we are going to discuss GFG Weekly Contest 144. So guys, please give me a +1 in the chat if you can hear me clearly, and then I'll quickly introduce myself as well so that we can start with the discussion. And let me know in the comments how many problems you were able to solve as well. So yeah, let's just wait for everyone to join in. Hi Joel. Okay. So I'm taking weekly contest after a long time. Okay. Yeah, so I'll quickly introduce myself, guys. So my name is Yash Dwivedi. I'm working as a software development engineer at GeeksforGeeks. Besides this, I also teach data structures and algorithms and competitive programming at GeeksforGeeks for the past 2.5 years now. So people are saying that only first and third they were able to solve. Okay, runtime error. We'll see to all of that. Okay, so I hope that everyone is ready. Just quickly give a hit the like button, guys, and give me a +1 in the chat so that I can understand that everything is working fine in terms of network and connectivity. And then I'll start. Okay. So let me quickly open the contest here so that we can start our discussion. So I will just quickly share my screen now so that we can discuss. First of all, I'll give you an first of all, what I will do is I'll give you a quick overview about the contest, and then once I have given the overview, like for every problem what could have been the possible approach and what I thought initially and how I optimized the approach. Okay, first of all I'll discuss that, and then after that, slowly and steadily, we will code every problem up. Okay, that is what the idea is going to be. So what we can do is we can open GFG practice quickly. Okay, and let's say we'll open this link now, and we'll open the contest, get internship weekly contest 144. The contest is over now. Okay, now let us quickly click on the solve problems. Yes, so I guess these were the problems that were given to you in the weekly contest 144. Okay, so I hope that everyone is ready. Now let me quickly discuss what was the idea about all the problems, and let me overall discuss that what is the level of the contest. So the first problem is basically chocolate distribution, and in the question number one, that was nothing but chocolate distribution. So let me write it properly. Yes, so the question number one that was there, that is chocolate distribution. Chocolate distribution. Now in this particular problem, you just had to apply a little bit of kind of a greedy approach, you can say, and two pointer, right? So it was very easy approach for solving this problem. If you regularly do code forces, or even if you do two pointer based DSA problems, then you will be able to solve it. Talking about the next problem, that is the second problem, which was another lucky string. So another lucky string was a little bit on the harder side for those people who don't do competitive programming regularly, because what happens is, in this particular problem, another lucky string, initially you might feel like that this problem is based on sliding window. Okay, people might feel that this problem is based on sliding window, and maybe many people might have used a sliding window or some approach of similar kind to solve this problem, but actually this problem was based on observation. Okay, what you in order to solve this problem, you just needed some observation. So actually, if you solve code forces, or if you solve problems on competitive programming platforms, then it is much easier to get the observation that how you can solve such kind of a problem. The solution is just 2 or 3 line based, but it is just that we have to decompose the solution, that how that what can be the answers. Either the answer can be of this much length, this much length, or this much length. Okay, so this is what we had to think, and then it was easy. Talking about geek conference, so geek conference was the third problem for this contest, and geek conference geek conference, you can say, uh, in this particular problem, I'll say it was a direct problem. It was a very easy problem. Why? Because if you know about disjoint set union data structure, okay, then by reading the problem itself, you will understand that the problem is asking you to implement disjoint set union, and it was very easy, right? Then after that, the fourth problem was there, that is jump game X. Okay, jump problem X, let's say jump problem X. Now talking about jump game X, this problem was using some concept, right? Because you had to find the maximum element and the minimum element, okay, on the right side or something. So that is why the stack concepts will come into play. And since you had to find the minimum number of jumps now, so you also have to use the Q or the DQ data structure. Okay, so this was the approach for the last problem. The last problem was not that tough, but it is just that you have to relate the things, that in order to find maximum and minimum, you can use some kind of stack, that is next greater element on the right side, next smaller element on the right side, something like this. And then you can use the Q approach in order to find the shortest jump, okay, the minimum number of jumps in which you can reach your destination. Clear? Please write +1. Does that make sense? Without seeing the question, how can you type this problem is there? I have read this. I was reading the contest while it was going on. No? That is why, Rafiq. I was reading this contest. Okay, so can we start? You can give me a +1. And please hit the like button, guys, because the like count is very less compared to the number of people who have joined. Okay, so let me start with the very first problem. And so we'll open this problem. Just 1 second. Let's open the coding problems here. Okay, so the first problem is basically chocolate distribution. Right, sir, second में टेस्ट केस गलत था. I don't think so, but if that is the case, so I'll see while I'll be solving it in front of you. I'll see that. Okay, guys. So yeah, I am starting off with the discussion now. The first problem is chocolate distribution. It says that you will be given n number of children. Okay, so you have been given n children here. So that is one thing, that you have been given how many children. So let's discuss this problem now. That is chocolate distribution. So chocolate distribution, right? So distribution. Now in this problem, they are saying that they will give you n children. Okay, n students or n children will be given to you. You can say n children will be given to you. So basically, you will be given an array which will be consisting of n elements here, right? So you will be given an array which will be consisting of n elements, and let's name that array as ARR. So this array name is ARR. Now in this particular array, for the ith student, the craving has been given. Okay, that what is the craving factor for the ith student? So for the ith child, the craving factor is ARR of I. Okay, now another array has been given, that is BRR array. Now in the second array, that is BRR array, what does it indicate? So the jth element of the BRR array is there, and it says that the second array is of size m, and what you have to do is you have to make sure that if you want to satisfy a ith student, suppose that you want to satisfy the ith student, right? So he will be satisfied if what happens, an ith student will be satisfied if the criteria is satisfied such that suppose that there is an array BRR also. So the ith student will be satisfied when for a particular ith student you are choosing, suppose that there is a ith student, right? And there is a jth index, jth element of the BRR array. So the ith student will be satisfied if and only if the ARRI value is less than equal to BRR of J. If this condition is satisfied, then the ith student will get satisfied. So for solving this, it is very simple, that you want the maximum number of children to get satisfied. If you want the maximum number of children to get satisfied, then what should you do? Understand one thing, guys, that suppose that if I had a student which had the value 7 here, suppose that ARRI value was 7, and suppose here the J value was, let's say, 20. Okay, so you might tell me that 17 is less than equal to 20. So you will tell me that let's count this child, because this particular child with the craving is 7, it will get satisfied, right? It will get satisfied. But the problem is, the thing is that what will happen is, suppose later on, if there is a student which is having craving, let's say as 18, suppose that there is a student later on which is having the craving as 18, and now inside your second array, suppose that the elements are like 17, then let's say 12, and let's say 13. Okay, these elements are there. Now this particular child which is having the craving as 18, okay, the child which is having the craving value as 18, it will not get satisfied. Why it will not get satisfied? Because of the simple reason that you have already used 20 to satisfy the child with the craving as 7. So that is why, in order to maximize, you can say that the child with the craving 7, the child with the craving as 7, it could have been satisfied with the child with the craving as 12 also, no? Are you getting my point? That the child with the craving as 7, it could have been satisfied with the value as 12, because 7 is less than equal to 12. So child with the value as 7 or with the craving as 7, it could have been satisfied with 12, right? And if we do that, then later on, if we still keep 20, if we still save our 20 for 18, then 18 will be less than equal to 20. So another child will get satisfied. Right, so this is how you can maximize. So basically the idea is that you will sort both the arrays. Okay, you will sort the first array and you will sort the second array also, and then you will apply your approach. Is that clear? Please write yes in the chat. Is this part clear to everyone? Please let me know in the chat, guys. Does this make sense? Why am I doing? Why we are required to sort, and why we need to use this kind of approach? Please give me a +1 if you are clear, guys. Are you clear with this? Right. Nihal says yes. Rohit says yes. Are you clear with the intuition? Especially for those students who were not able to understand this. Because if I want to satisfy, suppose if I would have satisfied 7 with 20, then later on for 18, I will not have anything. Now, so that way, that is a problem. So indirectly, I have to do what? For 17, I will satisfy it with 12, suppose. Then what will happen is 20 will still be left. So 8 for 8, the child with the craving as 18 can be satisfied with the value as 20. Right. So that is what I have to do is I have to sort both the arrays, and I have to iterate in both of them from the starting, and then in that case I will be able to maximize the number of students who get satisfied. Okay. Yes, I will try to go a little bit slow. Okay, I thought it's an easy problem, that is why. Live after a very long time. Yes, Joel, I am coming live after a long time. Is that clear? Guys, please give me a +1 in the chat if you are clear. Can I try to now discuss the approach further? So suppose if you have this array that is, let's say I will take one array of my own. Suppose that if I had one array, so what I will do is, first of all, I'll sort the ARR array. So I will sort the ARR array as well as the second array also that is there. I will sort it as well. Okay, so I'll sort the BRR array as well. Now, once I have sorted this, so suppose that this is the BRR array that we have, and suppose that this is the ARR array that I'm having, right? So what you will do is, suppose that the values here were, let's say something like, I had something like 12 here, then I had something like 15, then I had 17, then I have 21, then I have 24, and then I have 30 here. Okay, and suppose here what I have is I have got 7, then I've got something like 16. Okay, then I've got 17, then I've got something like, let's say 25, and then I've got element 26 also, right? Suppose that these are the elements that I have got. I tried all the solutions but was not able to solve any of them. No problem, Sahil. Every master was once a beginner, right? So yes, if you will see here, so I will mark my count of the students, satisfied students, as 0, and then I will start iterating. So my ith index will be here, and my jth index is going to be here. Now what will happen is I will check. So what I will check is that is the value 12 less than equal to 7? Because you have to satisfy this criteria, na, that you have to satisfy the criteria that ARR of I, if it is less than equal to BRR of J. Okay, so is this J satisfying that criteria? Tell me, is 12 less than equal to 7? No. So this BRR is not able to satisfy. This BRR element, this jth element of the second array, it is not able to satisfy the criteria. So since it is not able to satisfy the criteria, so what you will do? You need to do J++. Okay, if the BRR of J is not greater, right? If the BRR of J is not able to satisfy the condition that it is greater equal to the ith element of the ARR array, then you need to move your J index forward. So you will move your J here. Okay, you will move your J to the element 16, guys. Okay, the moment you move your J to 16, yes, second problem is also interesting, traveling. I will just do it just after this. Okay, don't worry. So yes, what will happen is now 12 is less than equal to 16. Okay, since the value 12 is less than equal to 16, so I'll say that yes, I will mark my count as 1. Okay, and then you can indirectly say that 12 and 16 have been satisfied, right? 12 is satisfied by the value as 16. Then since this is satisfied, so I need to move my I and J both pointers. So I will move to 15 and J will move to 17 here. Now in this case, is 15 less than equal to 17? Yes. So again I can say that the criteria is satisfied and my count will increase to 2, and then again I will move my I and J indexes by 1. So I will move now to 17 and J will move here. Okay, now what happens? You can say that 15 is satisfied by 17. Okay, after this, is 17 less than equal to 25? Yes, 17 is less than equal to 25. So since 17 is less than equal to 25, so you will say that now the count will increase to what? The count is going to increase to 3, and now 17 will get satisfied by 25, and then after this I and J both are going to move. So what will happen is now my ith index is, let's say, going to move here, and my jth index is going to move here. Now what happens is that again, suppose I will check. So let's say I will change the value here. Let's say instead of this, if I'll mark this as 27, I'll mark this as 29, I'll mark this as 30. So now this is the ith element and this is the jth element. So is 27 less than equal to 26? No, it is not. So then what I need to do, I simply need to move my j pointer. So when I'll move my j pointer, then I'll go out of the grid. When I go out of the grid, that is out of the second array, so I have exhausted one of the arrays. Since I have exhausted, so I will just return my count, that is the number of students or the number of children that I was able to satisfy, where and here the count is coming out to be 3. Is this part clear to everyone, guys? Please tell me. Is this question clear how I am doing it? Please tell me, then I'll quickly code it up as well. Okay, so far everyone is clear, especially for those who were not able to do it. Are you clear with this question, guys, so far? Okay, and please hit the like button if you're clear, guys. Okay, just as an acknowledgement, please hit the like button. Okay, so yes, what you need to do is, first of all, the scenario is that I need to sort the array. Okay, so let me just uh, zoom in. Okay, so what are the things that I need to do here? Firstly, the criteria is that I need to sort the array. So I'll sort the first array as well as the second array. So array.begin, comma, array.end. Why I'm sorting? Because I want to maximize the number of students who are satisfied. Then I will sort the second array also. So what I will do is I'll sort brr.begin, okay, with brr.end. So I'll sort the first and the second array. Once I have sorted the first and the second array, then what I should do? Then we will say that I pointer will be 0 and j pointer will be 0. I will be pointing to the first array and j will be pointing to the second array. Now what I will do is I'll say that while the I value is lesser than n and the j value is lesser than m. So basically both the pointers should not exceed. Then what I should do is I have to count. So I'll mark a counter variable initially as 0, that is the number of students who are satisfied. Now if it happens that the ith element of the array, if it is less than equal to brr of j, okay, then what I should do is I should simply increase my count, because I'll say that this ith student also gets satisfied, and then I should move away from this ith student as well as this jth element of the second array. Otherwise, if the jth element of the second array is not able to satisfy the ith student, then for satisfying that student I will move to j, then we will move to j++. So we will try to find a higher value in the second array. Okay, this is how it will work, and then at the end of the day you just need to return your counter here, that is basically the number of students which got satisfied or the number of children which got satisfied. Okay, so let me just quickly run this. Okay, it is working fine on the samples. Let me try and submit this. Hopefully it should get accepted. Okay, yes, it does get accepted. So is this problem clear to everyone, guys? Please tell me, is this problem clear to all of you? What I will do is I'll just share the link of this problem also. So let me open the GFG IDE here. Okay, and I'll share the link of this problem. You can write clear in the chat and give me a +1 if you are clear with this problem. And yes, you can use and in C++. You can use and is basically and. Like either you can use a and d or you can use and. In C++, latest version of C++, a and d can be used or and can be used. Both can be used. Okay. So yeah, I am giving the link of the first solution here in the chat. Okay. So solution 1. Okay, and you can paste it in some AI to get the respective code in other languages also. You can ask some AI to convert it into another language. Okay, so can we move forward? Please write next in the chat. Can we move to the next problem now, guys? I hope that we can. So the second problem is very interesting, and the second problem is given another lucky string. So actually, if when I was solving this problem, now how many of you were not able to solve it? Tell me, were you able to solve this problem, or you were not able to solve this problem? Or suppose when you were solving this problem, so what was going on in your mind? Please tell me about that first of all. When you were solving this problem, that is another lucky string, so what was going on in your mind, guys? Just a second, what happened? I will just decrease this. Okay, I solved the third problem. Second one was crazy. Next. Okay. It takes sixth attempt for me to solve, Ganesh is saying. I thought sliding window. Time limit exceeded. Okay, brute force was giving time limit exceeded. Actually, this problem was very easy, guys, right? What you had to do was, you had to observe what happens in such kind of problem. When the problem, I read the question wrong, Amit says. Okay. So I cracked, then Pranav Mittal is saying that I have solved in cube time. Then Harsh is saying I used map and count element and decrease until the condition is true. Okay, then sliding window, three loops. Okay, I thought it is similar to minimum window problem. Okay, so you were thinking a lot actually. The thing is that in this problem, your coding skill was not checked, your observation skill was checked. Okay, you can use sliding window and map in order to solve this kind of problem, because we are very much familiar that whenever we have to solve substring problems, then many of times we use sliding window. But actually for solving this problem you had to just use observation, right? So if you will see this problem, it says that you will be given a string s of length n. So let us write this. So the problem name is what? The problem name is another lucky string. So let me write this. The problem name is another lucky a string. Okay, another lucky string. Now in this particular problem, you are given a string s. So you are given a string s, and so this is the string that has been given to you, and the length of this string is n. Okay, the length of this string is n, so it has got n character inside it. Now find the length of the smallest lucky string. Okay, what you have to do is find the length of the, okay, length of smallest lucky string. Okay, what you want to do is you want to find the length of the smallest lucky string here. So smallest lucky substring. Okay, substring of s. So basically substring is a part of a string that is contiguous in nature. So what is a lucky substring? Okay, what is a lucky substring? Now suppose that if you have, like, what is the definition of a lucky substring? Okay, that we need to see. So what is a lucky substring? What is a lucky substring? Now a lucky substring has to be, at least the length has to be what? The length of the lucky substring has to be greater or equal to 2. Okay, a string will be considered as lucky substring firstly if its length is greater or equal to 2. So the length needs to be greater or equal to 2. Either 2 characters should be there or more than 2 characters should be there. That is one basic criteria. And it says that the count of the character a in the chosen substring should be more than b. The count of the character a in the chosen substring is more than character c. Okay, so what can be the possible scenarios? Suppose guys that if I choose a substring like this, suppose that if I choose a substring like a, okay, understand this fact. If there is a substring that if suppose that there is a substring which has 2 characters only, right? I'm just talking about the bare minimum. Suppose that there is a substring which has 2 characters. So suppose that the substring of 2 characters is aa. Okay, so in this case you can see that the count of the character a is greater than b, because a is occurring how many times? 2 times. B is occurring how many times? 0 times. C is occurring how many times in this? 0 time. So that is why one of the answers could be that one of the answers can be a kind of substring. Please write yes in the chat. Is everyone clear with this? One of the answers can be when the substring is a. When the substring is a, then the criteria is satisfied, because it has length of at least 2 and the number of a is greater than b and the count of a is also greater than c. Please write +1. Does that make sense? Does that make sense to everyone or not? Please write yes in the chat. We have to try and decompose this problem step by step. Okay, we have to use observation to solve this problem. So please write yes in the chat and hit the like button if you're clear so far. That is what I want bare minimum. Okay, very good. Very good. Everyone has to admit that they are clear, right? Now coming, so basically how can I identify that? So basically suppose that if the ith and the I plus 1th character are a, then I will return what? See this. If suppose that the ith character is equal to a and at the same time the I plus 1th character of the string is also equal to a. So can I say that in this case I should return what? In this case I should return the length as 2. Then my answer would be 2 or not? Do you agree with me or not? Tell me guys. If suppose that there is a substring of size 2, so how can you check the substring? Basically if the ith and the I plus 1th, if the ith and the I plus 1th means the adjacent characters both are a, then I can say that the length of 2 substring will satisfy my criteria. Correct? Correct now? This is clear? This condition is clear now? Okay, this is thought process number 1. Now suppose that even if you had suppose that if you had length 3. Okay, so suppose maybe what you had was, if you had something like if you had length 3, so can you consider what will be the case when the length is 3 guys? Can you consider the scenarios when the length would be 3? Anyone? Can you think about the scenario when the length would be 3 guys? Okay, suppose when the length is 3. So if you have 3 characters, so suppose that what you have is, if you have got a here, Okay, then suppose you have got B here, then you have got A here. Suppose this is the scenario. Okay, if this is the scenario now, then here the count of A is how much? A is occurring how many times, guys? A is occurring A is occurring 2 times. Okay, B is occurring how many times? B is occurring 0 times. C is occurring how many times? C is also occurring 0 times, right? So in this particular case, B is occurring 1 time. I'm sorry for that. So yes, you can see here that this also satisfied. Otherwise, another scenario can be that suppose if I have length 3 and I have got A, then C, and then A. Suppose something like this is what I have got. Okay, if suppose that adjacents were same, then AA already I have discussed. When we have AA, that already we have discussed that case. Now suppose we have ABA kind of a scenario. If you have ABA, then also this length 3 will satisfy. Or if you have ACA or ACA also, then also it will satisfy the required conditions. So in this case, if the string is like this, so you can say that if the I and the I plus 2th character, okay, if the ith character and the I plus 2th character are equal to A, if the ith and the I plus 2th character are equal to A, then the length string of length 3 will satisfy my criteria. Can I say this? That if the ith character is equal to A, okay, and what? And the I plus 2th character. So basically, this character and this character. So skipping one character in between, which can be either B or C, anything, or it can be anything, we don't care. So if it is equal to what? If both are equal to A, the I and I plus 2th character. So this means that a substring of length 3 will have 2 A's and 1 B or 1 C, depending on the scenario. So here you can see that A will be occurring 2 times, C will be occurring how many times? 1 time, and B will be occurring how many times? 0 times. So this will satisfy, and you will return that the length can be 3. Is that clear, guys? Please tell me. Is this part clear to everyone? Please tell me. Is this part also clear? Please write clear in the chat or +2 in the chat. Is the second thought process also clear to everyone? Is it clear? Please hit the like button if you're clear. I'm explaining in very much detail. Okay, let's discuss fourth before this thing. I will go sequence wise only. Okay. Noob guitarist. Right, this part is clear. Can we move further? Please write next in the chat. Now there is one last observation that you need. Okay, there is one last observation that you need. Can we move to the next condition? The next observation that we needed to have. Can I move to that? Please tell me, guys. Can I move to the next observation? Yes. Suppose that if the length was 4. Okay. Suppose that when can be the length 4? When can length 4 be the answer for you? Okay. When can the length 4 be the answer? So length 4 can be the answer in cases where suppose you have got what? Suppose that if you have got something like A, then you have got B, then you have got C, and then you have got A. Okay. If you have got A, B, C, A, so in this case, you will say that yes, A is in majority because A is occurring how many times? 2 times. B is occurring 1 time. C is occurring 1 time. Right? So here also you will say that the answer is there, existing. So you will say that if the ith character and I plus 3rd character, I plus 3, I plus 1, I plus 2, I plus 3. Yeah. So you can say that if I and I plus 3rd character is A. Okay, this is one scenario. Or what might happen is, suppose the other scenario can be that if I have got something like A, then I've got C, then I've got B, and then I've got A. If I've got this thing also, then also this criteria is satisfied. Now, A is occurring 1 time. Sorry, A is occurring 2 times, B is occurring 1 time, and C is also occurring 1 time here. Okay, so in this particular case, you can see that the criteria is satisfied, and this also, like you can say that the answer will be of 4 length. Okay, answer will be of 4 length. Here also the answer will be of 4 length. Is that clear, guys? Right. That if the I and I plus 3rd character, there is a case that we need to consider. But if I and I plus 3, okay, if I and I plus 3, both the characters are equal to A, then the answer will be 4 length. Can I say this, guys? That if the S of I and the S of I plus 3, if they are equal to A, right? If they both are equal to A, then the answer can be possible. But we have to consider one more thing. Is this part clear? Right, that the length 4 can be this. Now you need to consider one more thing, that suppose that if you have the length as 4, suppose that you have the length as 4, that is fine. But if you have A here, and you have got B here, right? So will this case be considered? Will this case be considered as an answer? No, because A is occurring 2 times, B is occurring 2 times, and C is occurring 0 times. So A is not occurring more than B. So this case should not be considered. Okay. For this kind of case, you should not consider. So basically, you have to satisfy the criteria that the ith character and the I plus 2th character, I plus 3th character, they both should be equal to A. Okay, both should be equal to a, and at the same time you can say I plus 1, I plus 2, I plus 3 here, right? So ith and I plus 2th character both should be equal to a, and at the same time you can say that I plus 1th and I plus 2th character should not be the same. Okay, should not be the same. Is that clear, guys? That ith and I plus 3th character, I and I plus 3 should be same and equal to a, but at the same time, the middle characters that are there, they should not be same. They should not be b or c. Okay. So another scenario where it is not possible. So for this case, it should not be possible. Okay. For this kind of case, you don't want the scenario to be possible. Another scenario that I just want to write is a, and then you have got c, c, a. If you have got ACCA as well, then also there is a problem. Why? Because A is occurring 2 times, C is occurring 2 times, B is occurring 0 times. So the problem says what? The problem says that the count of A is more, but here the count of A is not more. Okay, so this case also should not be considered. So basically, again, you can say that ith and the I plus third character, I plus 3 and I should be equal to A. That is one thing. And then at the same time, you can say that I plus 1 is not equal to I plus 2th character. So the middle character should not be the same. Is that clear? Please write yes in the chat. Is this part clear to everyone? Guys, are you able to understand this? Please write clear so far. If you're clear so far, please hit the like button and let me know if you're clear or not. Okay. Does this make sense? Now, if you will consider length 5, suppose that if you will think about any length 5 or something, then always it will come under any of the criterias. Okay. Now, see, we have already discussed length. I will summarize this. So I have discussed for length 2. What is the answer of length 2 will be there when a substring of AA is there. Okay. When the ith and the I plus 1th character are same. Right. Then the answer for length 3 will be there. When? Answer of length 3 will be when you can say what? A, when the scenario is like A, B, A, or the scenario is like what? A, C, A. Something like this. Then you can say that when the I and I plus 2th character, when they are same. Right. Then after this, the length of 4, when can the length of 4 be the answer? When you have something like this thing. Suppose you have got A, then you have got B, then you have got C, and then you have got A. So when you have I and I plus 3, okay, then and I plus 1 and I plus 2 are not the same. Okay. Or you can say that another criteria will be when what? When you have A, then you have C, then you have B, and then you have A. So here also you can observe that you have I plus 1 here, you have I plus 2 here, then you have got I plus 3 here. So here you can easily see, guys, that I and I plus 3 are same, and I plus 1 and I plus 2 are not the same. So then the length can be either 2, 3, or 4. You might think about more lengths, but basically those lengths will come under any of these criteria only. Okay. So is that clear? We want to use a sliding window approach for this. It is almost turning to be a code forces problem. Yes, kind of. It is a CP problem only. So it should be 4 now, because the longest substring AABC. You want the smallest now. You want the smallest lucky string. Actually, you want, Saurabh, you want the smallest lucky string now. So that is why you will want the lesser length. Makes sense? I don't know how order of n square got accepted. Order of n square got accepted. Are you sure order of n square got accepted? It should not get accepted because the n value is given as 10 to the power 5. So n square will give you TLE, I guess. Okay. So is this clear? Please write clear in the chat. Is everyone clear with the observation? Many of the times, what happens is when we look at such kind of a problem, so we get a panic attack, right? You all think that what you have to do is now you have to apply your implementation skills and you have to solve the problem using sliding window approach. You have to solve using the map approach, right? You have to apply sliding window plus map, and then you will solve such kind of a problem. But actually the thing is that whenever such kind of problem is asked, especially when such kind of a problem is asked as the first, second, or third problem, then you should observe the interviewer is not interested, or the problem setter is not interested to see your implementation skill in this problem. Maybe you can implement using sliding window approach, but the thing is that you want to solve fast also now. If you want to solve fast, yes, fatafat, I will do X also, the last problem also, Ranjan, don't worry about that. It is also easy. It is just in the last problem, Ranjan, I will give you a hint. Basically, if you want to find the right maximum, guys, so or right minimum, so you can use next smaller on the left, next smaller on the right, that kind of concept, stacks. right? And then you can use DQ in order to get the answer very fast. For sir, for this thing, output should be 1, but it is showing this thing, BBCAA. It was showing 2. Yes, the output will be 2 now, because the output will be 2, Mohammed, because you have got double A's together now. Since you have got the double A's together, so that the last two A's are together now, so they will be the shortest answer. At least the string length should be 2 now. That is also what the problem says here. If you will read this, I'll show you. It says that at least the length should be 2. At least 2. Okay. Is that clear? So how did you think about this kind of approach? So Nihal, it will come with practice. Maybe today you're not able to do it, but if you continuously do code forces and GFG weekly contest, then slowly and steadily your brain will start working in that direction. Okay, remember the word smallest. Yes. Okay, so, no sir, n cube is also not giving TLE, but it was not proper n cube, it was optimized n cube. Okay, like you can share your code if you want. Sliding window, the thing is, why do you want to apply sliding window now? Like because if you apply sliding window, then your implementation time will be very high. Okay, instead of that, why not use just observations? Right, now let's discuss the test cases that have been given here. So it says that we have been given A, C, A. So you can see here that what I've been given is I've been given A, then C, and then A, and then I've been given C and then B. So I don't have to consider 5 length. You can see here that here the ith and I plus 2th character are same. So this particular substring I can consider. Okay, so my answer for this would be 3 only. Correct? That is what the scenario is like. I think the questions are getting hard. No, no, no. I don't think so. To be very honest, like it was not that hard. If they are planning to pay so much, then the contest was not that hard. Believe me. Okay. Then for the last test case, if you will see ACBA. So actually here you have the ith and I plus 2 it's I plus third. So they are same, and in between I plus 1 and I plus 2 are not same. So here the answer would be of 4 length. So actually the test cases that were given to you, no, they indicated the this thing. ये है sliding window. ये है sliding window. Basically, why do you want to apply sliding window when you can do it using observation? No? Bro stuck in sliding window approach from the beginning. Bro is stuck on sliding window. Okay, can we code this up? Please write code in the chat, and please make sure to hit the like button, guys. Please hit the like button if you have understood so far. Okay, this observation part. Okay, that yes, this was a good problem. Actually, this was a good problem. Okay, so problem setter OP, you can write setter OP in the chat. Okay, problem setter OP. The problem setter thought about this problem. He must have thought a lot about this problem, and problem setter OP, guys. Okay, problem setter did a good job. Problem setter did. He thought a very good problem. I'll say that. Okay, explain this ACBAA. So in this case, the answer will it exist? Let me just think. If you have got ABBA, so I guess the answer would never exist here. No? The answer would be -1, because for this particular case, Jatin, the answer would never exist, because if you consider any length, like there is no criteria that is getting satisfied here. No observation is getting satisfied here, because if you consider ABBA, then it is not satisfying. Then you consider ACCA, that is also not satisfying. So I guess the answer for this case would be -1, Jatin. Make sense? Okay. Then you have ABBA, yeah, so that will not get satisfied. It will be -1, obviously, yes. So let's try and code this quickly, guys, and see what we can do here. Okay, so yes, like I'll be given the string also. So what I can say here is that I will start my I from 0. I is less than n minus 1. I is less than equal to n minus 2. Why I will do I is less than equal to n minus 2? Because I want to check the ith and I plus 2th character. That is why. So what I will do is I'll check that if the ith character is equal to, so let me write this. If the ith character is equal to suppose A, okay guys, and the I plus 1th character, suppose if it is equal to A. So this is when you have a case of double A's together, right? Then you will return that the answer would be 2. Okay, that is the main thing. Clear? Another scenario is for 3 length. So then what you can do? I start from 0. I is less than equal to n minus 3. Why you are doing n minus 3 here? Because you want to check, because if you want to check for 3 length, then you have to run till less equal to n minus 3. So this part is clear, guys? Both हो रहा है. 7 होगा ना 7. No, 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 7. I am not sure whether that kind of case would be given to you or not. Capital S is in if condition. Okay, I'll write the capital S here. Okay, let me do I plus plus here, and then what I will do is I'll check that if the ith character, suppose that if the S of I is equal to A, and at the same time what happens is S of I plus 2, if it's equal to A as well, then in that case I need to return the length as 3. Okay, otherwise what you can do here is used, yes, 7, it satisfies all. That depends, like we can see. Okay, so yes, if you will see here, so I will be 0, then I is less than equal to, I guess, n minus 4 is what I should do here. Right, and then I'll do an I plus plus here. Then what I can do is, if the ith character is what, if suppose that the ith character is equal to A, okay, and the just a second, let me see this part. Okay, why am I coding it in Java? Let me just change the language here. Okay, so yeah, now it is getting colored. So if the ith character and the I plus 2 with I plus 3, if I and I plus 3 are equal to what? If I and I plus 3 are equal to suppose A, okay, and at the same time the I plus 1th S of I plus 1 is not equal to S of I plus 2. So then you can say that the answer would be possible and the length would be, let's say, 4 here. That is what I'm planning to think about. And then in the end, I guess I can return what? -1 if the answer is not possible. Let's see. Yes, I have checked in between. So S, small s was not declared. Yeah, I need to write capital S here. Extra colon is there. Okay, now let's try and run it again. Okay, so there is some bracket issue somewhere here. Yeah, so here I should close it. Now it will be fine, I guess. Let's see. Yeah, it works fine on the samples. Let's try and run this case. Okay. So it is running and it gets accepted, right? So is this problem clear? You can tell me, guys. Is this problem clear now? Please write clear in the chat and then I'll quickly share the code also. Just a second. Can we move further to the third problem now? Third, and then we'll move to the fourth also. Okay. Fourth traversal is a lot. This is not an interview. So you, since you, if this was an interview, then you could have thought about it like that. But since this is not an interview, no, so you want to code as quickly as possible. So that is why this can work. Okay. Right, guys. So let's think about this problem now. Can we start with the third? Please write 3 in the chat. Can we start off with the third problem? Geeks conference. So let me quickly write this. The third problem is basically okay. So yes, in the previous question, what if we will do? We'll find the longest string. No, you don't want to find the longest string. No, you want to find the shortest string actually. Okay, so yes, let's discuss this problem, Geeks conference. Now, the prerequisite is that for solving this kind of problem, you should know the data structure that is disjoint set union. There is one advanced data structure that is there, that is disjoint set union. Okay, so basically there is one data structure that is known as DSU, or it is also known as union find. Okay, it is also known as union find. So you have to use this data structure. You should just have a bit of knowledge about this data structure, right? You should have a knowledge like what is find function in this. Basically, you should have a knowledge about find function in DSU, and you should have knowledge about union function in DSU, right? If you have a basic knowledge, then this problem was very easy. So if just in case, yeah, I thought it but not revised. I didn't understand this problem at all. I mean three. Okay. Third problem, why three loops? What I tried DFS for every step. No, no, no. Actually, if you will see, the thing is that Kartikeni, the thing is that if you will try union find would be better for this. Yes, union find is better. I tried DFS for this. No, actually, if you try DFS for this kind of problem, then for every step you will, for answering one query, you will take order of n time if you are using DFS. So if there are n queries, suppose, then for one query you are taking n time, so for n queries you will take n square time now. So that is why you will get a TLE here. So that is why union find is better, because it will give you the queries in very quick time, and it will do the union also very fast. Okay, clear guys? Yeah. So now I am starting off with this. How many of you already know union find? Please do you already know what is union find or not? Just let me know about that. Just in case if you don't, then after this lecture, you can try and go to Geeks4Geeks and you can study the disjoint set union data structure. If you want, I'll share it. Disjoint set union GFG. Okay. So if you want to explore this data structure, so you can explore it from somewhere here, if you want to read more about it. Anjali is saying no. No problem, Anjali. Still, I'll try to explain as much as possible, although you don't know. If you don't know, then you have to write one thing. Okay, you have to promise yourself. Okay, no problem if you don't know this. In this, there is no issue if you don't know that. But this problem is using the disjoint set union. Okay, I'll tell you how I used to prepare myself. Whenever I used to solve a problem, suppose in a contest, okay, if I was not able to solve that problem, then after the contest was over, I used to make sure that before I sleep, I understand that what were the issues in my code, or what I did not know, or what data structure or what new algorithm was being used in the problem, such that I was not able to solve it because I did not know about it. So you have to promise yourself that you will start creating a habit that whenever you solve a contest, after the contest is over, if you're not able to solve the problem, and you realize that there is a new data structure that people are talking about in the discussions, and you don't know about that, then you will learn that data structure. And disjoint set union is actually a very powerful data structure, because problems of disjoint set union are regularly asked in companies like Google, they're asked in Amazon, Microsoft, as well as Samsung. Okay, please write +1. Do you promise yourself that you will do it? After today's lecture, you will go on the internet, you will learn about disjoint set union. +1. You have to promise yourself. You don't have to promise me. You have to promise yourself that you will do this. Okay, right guys? Can I expect this much? See, I'm not someone who will just come, explain the code, and go away. I just expect that you will get better with time. Whatever time you are spending here, it should make you a better coder. It should make you a better problem solver. Okay, so you have to promise yourself that yes, you will do so. Okay, because if you do so, like, see, learning everything, you will learn this, you don't know what to learn. So if something is being used, and I am emphasizing the fact that it is asked in a lot of companies, so now it is your responsibility that after this lecture is over, then try to go back home and try to study. Sir, do you do code forces? Yes, I do code forces as well. Like, I am a cadet master on code forces plus int max, Ankit Kumar says. Okay. Right. So yeah, int max. What is int max +1? Tell me. I'll ask you one question. Ankit is saying int max. So what is int max +1? Can you tell me? If you do int max, suppose, and you do +1, and you are doing +1, so it will become int min. Okay, it will overflow. This will overflow. Okay. Do you know this? Just making things like, what is your code forces ID? So you can do this like. You can search, like, you can search this ID, or just in case if you want to see, so I'll show you. This is my code forces ID. Okay, so yeah, you can see I've solved a lot of contests and a lot of ups and downs in this graph. Okay, and 297 and 927 and counting. Yes, it will overflow. Okay, can we move further to the third question now? Let's try and read it. So yeah, Ankit Kumar is saying minus. Okay, yeah, you can check that up. Minus something. No, minus intermin. Like it's like intermin basically. Okay, show your lead code profile. यहाँ मैं बोल I'm not here to display anything. I'm here to solve the problems. Okay, so yeah, I guess I've solved 400 plus there. Can you suggest more channels? Controversy हो जाएगी. Okay. So yes, if you will see here, Geeks conference. So let us understand this problem now. Third question could be solved using graph. Inside graph, there is a data structure. Like you can say that there is graph where you have BFS, DFS. You have a lot of algorithms there, but in graphs you have another algorithm or you have a proper data structure that is disjoint set union. And for solving the kind of problems that have been given to us, we can use the disjoint set union always. Like it, bhaiya question kariye na please. हाँ भाई start करते हैं. Can you explain this thing along with this thing? Not possible, bro. Yeah. I hope you can understand. Yeah, Geek is organizing a conference and he has invited several people. Okay, so there is a guy Geek and he has invited several people. Now he aims to facilitate the friendship among them. So he's going to make friendship. So what happens is initially nobody is initially you can say that nobody is friend of anybody else, right? So there's a conference going on. Suppose that there is a guy A. Okay, so there's a guy A, there's a guy B. Okay, then there is a guy suppose C, and then there is a guy D. Okay, suppose that initially none of them is friends, right? So initially A is restricted to himself. Okay, you can say that B is restricted to itself, C is restricted to itself, and D is restricted to itself. So basically what I'm trying to say here is that parent of A is what? Parent of A you can say is -1. I'm using ABC here, but in the question they will be using 0, 1, 2, but I'm using ABC so that you can understand it better. Okay, so initially you can say the parent of A will be -1. You can say that the parent of B will be -1. This basically indicates that like they are their own group. Okay, then you can say that parent of C will be equal to what? You can say that parent of C will be -1. Okay, then you can also say that what is going to happen is parent of D is also going to be -1 here, guys, right? So this is the main thing that is there. Now if you will see here, so the thing is that suppose that if I make A and B as friends, right? Suppose that what Geek will do is, so in this case, if you will see, so suppose that Geek will make A and B as friends. So let me just read this question. It says that now he aims to facilitate the friendship. So he start by introducing a pair of individuals within the group and introduce them to each other. Two individuals are considered to be friends if they are directly connected or if they are linked with mutual friends. Okay, so you can see here that suppose that if initially what will happen is initially you will mark your answer like initially you will say that the maximum group length is 0. Okay, there is like initially you will say that the maximum group length is 0, and then what you will do is also one more thing, we can have the size for every element. So you can see here that what I will do is, suppose if the Geek says that A and B are friends, like suppose that he is going to make A and B as friends, right? If he is going to make a friendship between A and B, right, then what should I do? If suppose that A and B meet, then I will say that either, then what I can say is that I will connect these two in the same component. So what I will do is I'll say that instead of B pointing to -1 or itself, now B will point to this guy. So what you can say is that now B is going to point to A. Okay, so you are going to make the parent of B as A. So instead of -1, now let's say it will point to A here. Okay, this is what is going to happen, right? That this is what is going to happen because initially they were different. Now initially both of them did not have the same thing. So now suppose that I have made A and B as like I have clubbed A and B together. Now what will happen is, suppose somebody tells me that B and C. Now suppose that Geek is going to make B and C as friends. Suppose that now you make B and C as friends. So what you can do is you can say that you can join C with B. Okay, so now you can make C's parent as B. Okay, so C's parent can now be B. If you do that, then what happens? Now C's parent is B here. Okay, now if somebody is going to ask me, now I'll ask you a question. Are A and C friends or not? Please tell me. Are A and C in the same friend circle or different friend circle right now? Look at the case and tell me. Suppose A and B are made as friends and B and C are friends. Are A and C friends or not? Please tell me, guys. right? Are A and C friends? Yes or no? That is what I want in the comments, guys. Tell me. As of now, look at the diagram. Look at the diagram and tell me. Are A and C friends? Like, are they in the same group? Are they in the same group or not? Because in this question they are saying now, if A is friend with C, B is friend with A is friend with B, B is friend with C, then A and C are also considered as connected. A and C are also considered as connected. How? Basically, for doing this, what you can do is you will find the ultimate parent. It is just like finding the parent. So when you have to find for A and C, no, so you can say that the parent of A is what? Suppose that you have suppose that you can see here that the parent of A is A itself, right? Because A does not have any parent. And if you will see, so what I can do is I can find the parent for A, okay, and I can find the parent for C. So for A, you can say that for A, it is its parent, its own parent. Suppose, right? Maybe suppose that you can mark this as A and D respectively. Suppose that this one was marked as A initially and this was marked as D initially. So yes, suppose every guy was its own parent. Now what will happen is parent of A is A, right? And when you find the parent of C, so how do you find it? It's a recursive process. If I want my parent, I notice one thing nowadays. GFG is asking better questions. That's a compliment. Thanks a lot. So yeah, I guess people are working really hard at GeeksforGeeks to make these things possible. Okay, so you should appreciate this effort. So yes, you can see here that when I have got C now, so for finding C, I want to find the parent of B. Okay, what the parent of B will be nothing but parent of C will be nothing but parent of B, and parent of C. For finding the ultimate parent of C, I have to call upwards to B, and B will call to A, and A for C, B is the parent, for B, A is the parent. So for C, you can say that the parent is A, for A also the parent is A. So since they belong to the same component here, no, since A and C both are belonging to the same component, because A's ultimate parent is A only and C's ultimate parent is also A. So that is why what will happen here is that you are basically going to say that they are in the same component, right? They are friends actually. So does this make sense? Please write clear in the chat. Is this part clear so far? Then I'll explain a little bit of find function, how you optimize the find function and other things. Right. So far you're clear. Please write +1 and hit the like button, guys. If you're satisfied so far, I'm trying to give my best effort since the last 1 hour. Like as much as possible, I'm speaking loudly. And if you have any doubts, you can tell me in the comments. Sir, what to do if nothing is coming in our mind when approaching a question? So Krishna, if something is coming to your mind and you're not able to solve it later on, like if you're not able to solve it during the contest, so it is your responsibility that after the contest is over, so you should try and solve the contest after it is over. Solve the problems that you were not able to solve. Try to see the discuss section. Try to discuss it with your friends. Or if suppose GFG is having something like this, so come in these sessions and try to solve it. For example, if I have told you that you should learn disjoint set union data structure, so go there and learn it. Make sense, guys? Now there is one problem with this. What is the problem with find? Can you tell me? Anyone can tell me right now? There is a problem. Suppose that a tree like this was made. Okay, I'll do one thing. Suppose that you did a lot of union functions. Suppose that you did what, like A's ultimate parent is A, suppose, and now B is pointing to A. Suppose that C is also pointing to A. Then suppose that D is also pointing to A. Then suppose that E is ultimately for all of these guys the parent is A only. So can you tell me, are A and E connected? Can you tell me, guys, are A and E connected in the same component? Please write yes or no. Are A and E connected in the same component or not? Okay, I guess I have not shared my screen. Sorry. Okay, yeah. So I guess now you can see my screen. So that is why I have this mobile, like I have this opened here also. So I just saw that my screen was not visible. Right. So yes, now if you will see, please share the screen. Yeah. Suppose that if I have got A, right, as the ultimate parent, and then B is pointing to A, then C is pointing to B, then D is pointing to A, and E is pointing to D. Now the thing is, if you will see what will happen if I ask you to find A, right, find the ultimate parent of A and find the ultimate parent of E. So can you guys tell me what will happen here? Can you guys tell me what is going to happen here? For A, the ultimate parent is A itself, suppose, right? Because it is -1, like it is pointing to itself. For E, the ultimate parent will be what? For E also the ultimate parent will be A. Correct, guys? For E also the ultimate parent is A. So are they belonging to the same component? Yes, they are belonging to the same component. But can I say that I had to do a lot of iteration here? Can I say that I had to do a lot of iteration, and then only I got my parent. Agree? Suppose that later on, if somebody will ask me that A and D are in the same component, or same component or not, then what you are going to do? Then you are going to say that find A and find D. Again, you are going to run it. Agree with me or not? So don't you think that again you are going to cross this path, and that will be a redundant operation, because you are again doing a similar operation? Are you getting my point? Are you getting my point? That earlier, when you had done for A and E, then you had iterated through this path. You had crossed this red color path, na? Like you had gone up. You had gone up doing the query, right? And now again for from D, now you are again going up. Okay, suppose I'll do it for C, then again you will run. So that's a, like, for every time you are running order of n length. Suppose in the worst case, if the length is n, so you are running this much length. Are you clear with this? Please write yes in the chat. Are you getting my point, that it is not optimized right now? The find function is not optimized because of the issue that we are running throughout. Clear? Please write yes in the chat. Does this make sense, guys? Does this make sense or not? Please tell me. Does it make sense for everyone or not? Yes, Ankit Kumar says yes. Nihal says yes. Jatin says yes. What about others? Please hit the like button, guys. Like, it encourages me a lot. It will encourage me a lot. Okay, so let's see if we can reach 70 likes or not. Okay, let's wait for 1 minute and let's see if we can reach 70 likes or not. Because I could have directly solved it. Like, भाई पिछले क्वेश्चन में क्यों फंसे हो? Basically, if you have got A na, so then the answer would be A only, na? That is the thing. If you are talking about the previous problem. So let's see if we can reach 70 likes, and then we'll restart. Can we? Okay. I'm just drinking some water. Till then, you can show me whether we can reach this much likes or not. Okay. Yeah, and you can see GFG's water bottle. 60 are watching. 30 has already done. What 30 have already done? It is impossible. Please continue. Okay, sure. I'll continue. Right. So yes, I hope that the screen is visible. Okay. Now, GFG Sipper. How to get GFG Sipper? I guess you need to crack an internship or a full-time offer at GeeksforGeeks. Then you will do it. Fourth question हो गया क्या discuss? No, we are going to discuss it. What we have to do? Join GFG? Yes, you have to join GFG for that, actually. Okay, so yes, if you will see here, this is very long. So what you will do is now, actually you will, this process will be known as, when you will read the, suppose that if you don't know DSU now, so in find function you will learn about this path compression process. Okay, you will learn about this path compression process. So what you will do is, when this will go up, suppose that for the first time when you will do the query for A and E only, now for the first time when you will do the query for A and E, then when you will go up, right, when you go here, then what will happen? Now this guy is going to return A. So now parent of B will be updated as A. Okay, parent of B will be updated as A. Then after that, what happens? After that, what will happen is, when you will go down, okay, so when it will keep on trickling the answer, so this will return A. Then B will also say that the ultimate parent is A. Right. So now, since you are getting an answer that the ultimate parent is A, so C now, instead of pointing to B, C will point to whatever ultimate parent is returned. So now parent of C would be updated as nothing but A here. Okay. And because of this, what will happen? Now C will start pointing to A directly like this. C will start pointing to A directly like this. Okay. Then what will happen is, after that, C will also trickle down the same effect downwards. So what will happen is, C will also say that the ultimate parent is A. So down here, the answer would be said that ultimate parent is A. Then what will happen is, now D, instead of pointing to C, I will ask it to directly point to the ultimate parent. Okay. Then after that, what will happen is, now going further, so I'll update the parent of D as what? I'll update the parent of D as nothing but A. Now after this, what will happen is, again we will have this element E, and then this guy's ultimate parent, now because we get A in return, so E's ultimate parent would also be updated as A, right? So parent of E you are going to update as A. Now because of this, what will happen actually, what will happen is, now the path will get compressed. Why? because once you have iterated here, no, so you will have A. Now B is pointing to this guy, right? Now C is also pointing to this guy. Now D is also pointing to this guy, you can observe, and E is also pointing to this guy. Basically, this particular diagram I have simplified, right? So you can see here that now the operations will be faster. Next time, suppose you have to check that whether A and D are in the same component or not. So it will be checked very easily, no? Are you getting? This is known as path compression. This process is known as path compression. Is the idea clear to those who are going to learn it today? Is the idea clear? Right. If A is a friend and then B is also friend here. So for question 2. Okay, guys, can we move further? See, don't worry if the problem setter has made many mistakes. We'll see that. But when I saw the problem, I thought like that only. Okay. Maybe the test cases might have not been that hard if you are saying so, but I was assuming that the question is correct. So, and my code got accepted. So, if there is any issue, you can submit your feedback. Uh, uh, like you can share it on a GeeksforGeeks mail if you want. Okay. Test case for second. Don't think about that. Can we proceed further, guys? Is this idea clear? Please write yes in the chat. Is this path compression idea clear? That not only you're going to find the path, but also you're going to optimize it. Is this much part clear? Please write +1 and then I'll proceed further. Is that part clear? Is that part clear, guys? Tell me. So far, is that part clear? Then I'll also talk about the union part, like why union, or union also you will do an optimization there. Makes sense? Can I? Just a second. So yeah, just give me a minute, guys. Okay, so yeah, let's proceed further. So yes, if you will see here, in this particular case, the scenario is like, suppose that there is another. So there are two things that are there. I've already explained the path compression part. Okay, path compression. I've already explained that you will update the parent. Okay, so you need to learn this if you are new to this data structure. Now let us talk about union by rank. Okay, union by rank. Why it is also important? Because suppose, guys, that if you have this thing, suppose that if you have what? Suppose that you have got A here, okay, and ultimate parent of A is A. Then you have got B here, okay. Then suppose that you have got C here. Suppose, okay. Then suppose that you have got D here. Okay, then suppose you have got what, like suppose that you have got X and then you have got Y here. Suppose you have got this thing, guys. Okay, so now what you will do, guys, you have to understand one thing. If you will see, I will ask you one thing. I'll ask you one thing, guys. Are A and X in the same component? Tell me, are A and X in the same component? Please tell me, guys. Are A and X belonging in the same friendship group or not? Please tell me. Are A and X both belonging in the same component? No, they are not. They are not. Their parent is not the same. Their ultimate parent is not the same. Correct. So what I will do is, there are two scenarios that I can develop from here. What are the two scenarios that I can have from here? Either I can do what? I could have done it like this. There are two scenarios. So I'll draw both of them. Either I would have said that I will do what? I'll make A as the ultimate parent still, and I'll say that now, like it will be like this, B, and then you'll have C here, and then after that you'll have D here. Okay. Then what you will have here is, you will have X here, and then you will have Y here. Okay, this is one thing that you could have done. Or so basically what you could have done is, you could have made the parent of, you could have said that the parent of X will be made as A. Okay, this is one thing that you could have done. Other way that would have been possible is that if you had, suppose if you had A, okay, suppose that if you had got A, suppose that you would have made X as the parent. Okay, so X would still have been the parent, and then you had got Y here. Okay, then you had Y here, suppose, right? Then after this, you had A pointing here. Now you had got B, right? Now you had got C. Now you had got D. Suppose you had this thing. So basically, I know that I can solve this within couple of seconds. I know that for those who are thinking, I know that I can solve it within couple of seconds, because if you already know the data structure, then it is very genuine and it is very easy to understand that this is union by rank or union by size. But for those who are new to this, I am explaining them so that later on when they will go back and study this, so things will make sense for them. Okay, my purpose is not only solving or giving the code. My purpose is to make your understanding of the data structure or whatever we are doing better. Make sense, guys? Okay, now are you okay with that? If you want, I can directly code that up. There is no problem. But the reason why I'm explaining that union by rank or union by find also, so that later on when you will rediscover the data structure again, then you will have a better understanding of it, so that your time is not wasted later on when you'll study it again. Okay. So if you will see here, what is the issue? What is the issue? Like, can we make anybody's parent as anybody? Right? Can we make the parent without thinking? Because if you will see, what is the length of this path, guys? Can you tell me? What is the length of this much path? Can you tell me? The length of this much path is 4. What is the length of this much path? 2. Okay. Now, if you will see here, the thing is that in this particular path, if you will make A as the parent, okay, whichever has the highest, suppose that rank of, like, you will say that A is having what, like, you let's say I'll name a rank. So for A I will update the rank as 4. Okay, why I'm updating the rank as 4? Because you can say that there are 4 elements that are attached to it, and for X I am updating the rank as 2, because it is connected with 2 people, right? There are basically 2 people in this, right? So it will be updated by rank. Now if you see, suppose if I make A as the parent, now what is the longest length? What is the longest length of the path? Can you tell me? In this white diagram that I, please tell me, in this diagram, in this one, please tell me, guys, what is the maximum length from the bottom to the top? Can you tell me? If I still make A as the parent of X, then what is the maximum length? Can you tell me, guys? Please comment in the chat. Please comment. Still the maximum length is nothing but 4 only. Okay. But what if I have made X as the parent? If I made X as the parent, then A has to point here. Okay. If I made X as the parent, then A had to point here. So now what was the length? If you will see here, now this length became what? 5. Correct. If you made X as the parent, if you made the guy with the smaller rank as the parent, then what happened was your length of the path increased, right? So this is not a good thing, because if your length increases, this will cause a trouble. This might cause a TLE also for some time, right? So that is why you will merge in which guy, whichever guy has the largest, whichever guy has the higher rank, na, that will be the parent. Okay. So if X and Y are there, so which guy will be the parent? A will be the parent, because A has the higher rank already. Okay, because otherwise if you will attach the higher guy to the smaller guy, then the length will increase. Is that clear? Please write clear in the chat. Is that clear to everyone, guys? Is that clear? Please write clear in the chat. Why do you think that the answer is 7? Because Ankit, you have to understand one thing, that A is occurring 3 times, B is occurring 4 times in your test case. A is occurring 3 times, B is occurring this much time. Like, it would not be possible, man. Like, try to think about it again. A is don't focus on this. I think the test case was correct, but if you feel anything, then you can connect with the GFG team. Like, you can mail them or something. But as far as I saw that, I did not think about that. I just thought about the observation. Okay. So don't think that much. Okay. So is this part clear? Please give me a +1. Heavily, please give me a +1, guys. Does this make sense? Union by rank also? Yes or no? Union by rank is making sense for everybody? Okay, na? Clear? +1 in the chat, guys. Like, why did I do this? Like, why you always need to make the parent which the guy it will be the guy which has the higher rank will be the parent. Otherwise, if you make X as the parent, then the length of the path would increase. So these things must be clear, right? Can I write the code now? A lot of discussion was going on in the chat now. So yes, let's try and write this. So what I should do here? So basically, I can do what? I can make a class of DSU for myself. Okay. So let's say inside this class, I will make a DSU class, disjoint set union class, because I need certain functions that I will be using. So what I will do is I'll just declare this class and I'll put a colon here. Okay. So what I'm doing here is I'm declaring my DSU class. Now inside my DSU class, what are the things that I want? I want the parent. So let's say I'll declare a vector int parent. Okay. Parent array is what I need to declare. And then I also need to have a rank array. So let's say I will have vector int, let's say rank. Okay, so these are the two things that I will be requiring because of the data structures basic requirement. Then after that, I can have a constructor, let's say, and suppose that the number of elements are n. Then what I will do here is I will simply say that if suppose that the number of elements are n, so we can say that we can start our I from 0 till I is less than, let's say, n plus 5, because I will declare 5 size greater. So that's why I'm thinking to name it like this. Okay. Then initially, let's say parent of I can be marked as -1. So, or let's say I can do what? I can do parent dot pushback -1. So initially I'm marking everyone's parent as -1. Okay. And then I can say that rank dot pushback 1. Initially everybody's length would be 1. Na? Or should I mark it as 0? That is what I need to think. Let me mark it as 0. Initially, you are connected to nobody else, so I will mark the length as 0, rank as 0. Is this much part clear, guys? What I am doing here? Is this much part clear? Please tell me in the chat. Yes or no? Is this much part clear, guys? Initially, I'm marking everyone's parent as -1, and initially I'm marking the rank as 0. Okay, na? Okay, okay. So yeah, you are not responding in the chat now. That is why I was waiting, guys. Okay. I don't want to reset the code. Yes. So after this is done, then next up, what should I do? After I have declared the DSU, then I should have the int find parent function, like inside this only I should have. Yeah. So let's say what I will have is I'll have a int find function. Okay. So this will help me to find the parent. So let's say if for A, I want to find its parent. So suppose that if what happens is if I have to find the parent, right? So suppose if the parent of A is equal to -1, what does that indicate? It indicates that you have reached the ultimate parent, so you will return A only, right? If you have this thing, then you can say that you will do this by making the parent of A as A itself also, right? So you can say that if you're currently you're at a guy which is whose parent is -1, so that is the ultimate parent, right, of that component. So you will say that you will update A's parent as A itself, okay, and then you will return this thing, okay. Otherwise, if that is not so what might happen is, let me think, if the parent of A is equal to -1, then I'll do this. Suppose if the parent, or it might happen like okay, let's say I'll return A, or let's say I'll do it like this only. Then what I can do is, if suppose that the parent of A was equal to what? If the parent of A was equal to A, then what I will do is, then I'll return A only, right? Because A is the ultimate parent. Otherwise, what I need to do is I need to calculate. So let's say I'll say that int I'll calculate the parent. So parent will be, for finding the parent, I'll call the find function. If for A I have to find the parent, so I have to move up. So I have to find my parent's parent. So I'll call for parent of A. And once I have found my parent's parent, then I'll update my parent as what? Then I'll update my parent as nothing but A here. Okay, then I'll update my parent's parent as nothing but the value here. Sorry. Yeah, I think this is working fine. Is this correct? I hope that this is correct, guys, right? What do you think? Suppose that if the parent is -1, so I'm updating the parent of A as A only, because that is the ultimate parent. If suppose it is A, then I'm returning A only. Otherwise, I'm finding, if I'm in a general case, so for A, I will find its parent, and once I find the parent's parent, then I'll update my parent as the value that I've got, right? So this is what I'm thinking, and then I'll return this value also. Make sense, guys? Yes or no? You can write it in one step also. Is that clear? I consider continue of count of A should be more than B and C. Look at the count, bro. Yeah, I guess in the last problem you they had mentioned this thing. You are using ternary operator. Which operator? Where? Okay, so yes, I guess this is how the find function can be written. Now let's talk about the union function. Do I need to write a union function specifically? I guess I can. So what I will do is I need to write a union function also. So let me just quickly write it up. So what I will do is, suppose that if I have to merge a and b, so int a comma int b is there, then what I will do is, if I have to do this, so suppose that I will find the parent of a. If the parent of a, suppose, is equal to the parent of b, so if they both are having the same parent, then do you need to connect them? No, you need to return from there. Otherwise, if both the parents are not same, then you will do what, guys? If the parent of both the people are not same, then what you will do? Suppose if the rank of a is greater than rank of b, then what you will do? If the rank of a is greater than the rank of b, then in that case, which guy you will make it as the parent? Can you tell me? See, one scenario can be that if the parent is same, then you will not do any union. Otherwise, if the parent is not same and the rank of a is greater, if the rank of a is greater, then you will say that, so just a second, what I should do instead is, I will write it like this. Let's say I will write it like this. Let's say int x is equal to find a. So I'll find for a and I'll find for b. Find the ultimate parent for a and b. Y will be equal to what? Find parent of b. So I'll find the ultimate parent of a and b. If they are not same, so I'll find them, and then I'll say that if the ultimate parent, suppose that if the ultimate parent of a, that is x, if it is having rank greater than y, then what should happen? Then I will say that the parent of y would be updated as x. Can I say this, guys? Yes or no? The parent of y would be updated as x right away. Otherwise, suppose what happens is, if the rank of this thing, if the rank of y is greater than the rank of x, then in that case, what I will do is, in that case, I'll say that the parent of x will be equal to y here. Okay. Otherwise, if both of them are having the same length, then you can make anybody's parent as anybody. So parent of x is equal to y, and since both of them are of the same length, so one length would increase. So you'll say that rank of x can be increased by one, because if x is becoming the parent, whichever guy is becoming the parent. So let me think. If suppose that both of them were of the same length, suppose that you had this, okay, and this guy was pointing here, then you had this guy, this guy, this guy, this guy, and this guy, right? So if they are of the same length, then suppose that you this guy is x, this guy is y, right? So if you connect, if you are doing what, if you are making the parent of x as y, so you are connecting this guy here. So then what will happen? Like y is there, then o is there, like then this guy, and then after that, here you will have x, then here you'll have o, and then here you'll have another o, right? Like basically not o, basically certain element that I don't want to write. So the y, whichever guy is becoming the parents, its length would increase. You can see here, if both of them have the same length, if this guy has the length as 3, if this guy also has the length as 3, then later on you can make anybody's parent as anybody, and then suppose that if you're making the parent of x as y, then in that case, what will happen? The rank of y should increase. No, please write plus plus in the chat. Why it should increase? Because now this path is of 4 length. Na? Make sense, guys? So yeah, you should do parent of y plus, or rank of y plus plus. Whichever guy is becoming the parent, its length would increase. Is that clear, guys? Yes or no? Please tell me. Judge code is not is working, I think. Okay. DM me in Discord. Okay, so yeah, can we proceed further, guys? You understood this part also, like the last part that I explained. Whichever guy is larger, that will become the parent. If both of them are of the same length, then whichever guy is now going to become the parent. Suppose if you make y as the parent, then the rank would increase if they had the same length. Clear? Sham says yes. What about others? Others are also able to understand this or not? Guys, please tell me. Union size is more simple. Yes, union by size is more simple. I agree to that. But yeah, since I was writing in terms of rank, so I just wrote it in terms of rank. There's both are same, guys. No worries. Okay. Now what you need to do is you can simply declare a DSU object here. So let's say I will declare a DSU object. Let's say D, and I'll pass whatever n value is given. Let's say I'll pass n plus 10 here. Okay. Or something like that. Although I can pass more also, but let's just pass this much only. Now once I have made this, so I need an answer, vector in answer, because every time I club so what I have to do is, if you will see, so 1 and 2 will be made as friends, so the component size will increase by 1 and all those things are going to happen. So I guess for every guy I can initially keep the size also, right? For every guy I can keep the size of its component. So let's say I'll make it as n plus 10. So for every guy, initially I'll mark the size as 1. Okay, initially I'll mark its size as 1. then I'm having this answer. Now I will suppose I'll iterate for all the queries. So let's say auto I is to ARR. So what I will try to do is, now if I'm trying to iterate, so what I will do is, let's say if I'm trying to iterate, so there can be two elements that will be given, no? Yeah, P and Q will be given at a particular point of time, suppose. So int P will be what, let's say I0. Okay, then int Q will be what, I1. So basically, if I is indicating the pair, okay, so the 0th element of the pair will be P and the 1th element would be Q. Now if I have to merge them, so what should I do? I will say that if d dot find, okay, if the find of this P is not equal to find of Q. So if what does this mean, guys? If I try to find their ultimate parent and their ultimate parent are not the same, what does that mean? Can you tell me? If I try to find their ultimate parent and they are not same. Also, one more thing, initially I'll mark the maximum as 0 for this particular call, because I need to keep the size of the maximum. I also want to know where I got my wrong approach in DFS. So what was your approach? DSU time complexity is 4, alpha is order of 1. Yeah, it's constant only. It's asymptotically, like I guess it's order of n overall whenever DSU is talked about. Right. So yes, you can see here that if the ultimate parent of P and Q are not the same. So suppose initially when you're going to start off, then what will happen for this particular test case? If you will see, so I'll just quickly do a dry run on this particular test case. Okay. So the thing is that you are going to have what? You are going to have just a second. Let me do one thing. Let me switch on my fans as well, because I guess the laptop is getting heated. Then we'll just finish up the code, don't worry. We are almost about to end the third problem, then we'll discuss the fourth one also. Okay, so yes, it is quite hot. Okay, so yes, you will do what? Understand this fact, guys, that suppose that if you had been given what, the pairs were given as 1 comma 2. Okay, then you were given what, 3 comma 4 was given to you, and then what was given to you, guys? Then 1 comma 3 was given to you, and then after that what was given, 2 comma 4 was given. Okay, so initially you will say that the maximum group size would be initially 0 only. Okay, and you need to store a list of answer after every query. Okay, you need to store a list of answer after every query. So initially what you will do is, initially you will get the P and Q as this guy. So I will check, are 1 and 2 in the same component? Tell me, initially are 1 and 2 in the same component? No, they are not in the same component. So maybe what I will do is, I'll say that now I'll connect them. So suppose I connect them like this, okay, and like this. Then what should I do? If I connect them, so initially what was the scenario was that the size of one was 1 and size of 2 was also 1. Initially both of them were single individual elements. Now after doing this, what should I do? Like after I have merged, so I should say that now the size, since I have made 1 as the parent, right? So now its size would be 2. Okay, and then I will also say that size of 2 will also become 2, because both of them, like basically one has got including itself, one has got 2 friends, and including itself 2 has also got 2 friends. But whenever you have to take the size of a group now, then you don't have to include that element. If you will see here, so in this case it says that uh, uh, he seeks to determine the maximum number of friends any person can have after the ith operation, excluding that element. So always you have to take the size of the, after you have merged, then you have to take the size of the P minus 1, size of the Q minus 1, kind of thing, right? Is that clear? Because you don't want to consider that element itself. Is that clear, guys? Is that clear? Please write yes or no. How can we send code? You can try to send it in chat. Maybe it might be visible to me. I work at GeeksforGeeks. Okay, does this make sense, guys? Yes or no? What I'm trying to say, does this make sense? That like basically what you will do is, your sizes initially, let's say you made the size as 1. Like you will say that 1 had 1 friend, then 2 also had 1 friend. Then after that, when you merge, so one size would be updated. Just a second. Yeah, guys, so what you will do here is, what you're going to do here is, you will do this, right? So now when you will take the size, so you will always do minus 1. Why? Because you want to exclude that element. So now, as of now, what is the maximum size? The maximum size is 1, because size of 1 is 2, size of 2 is 2, but minus 1 when you will do, so maximum is 1. So after first query, you will say that the maximum group size excluding the element itself is 1 only. Then after that, when you come across 3 and 4, then what you will do is you will say that 3 and 4 are individual elements right now. So now you will do what? You will make 3 and 4 together. So you will do the union. Now the moment you do the union, then what happens? The size of 3 will become 2. Okay, and the size of 4 will also become 2, including itself. But whenever you are taking the maximum, so you have to do a minus 1 and then consider with the maximum. So still the maximum is going to be 1 only. So even after this operation, you will say that the maximum is 1 only. Then after this, what you have to do is you have to check, are 1 and 3 in the same group? Tell me, guys, are 1 and 3 in the same group? Yes or no? Are 1 and 3 in the same group? 1 and 3 are in the same group or not? No, no. 1 and 3 are not in the same group. So then you will merge them. So when the moment you merge them, then what happened? You will say that now the size of 1 will be nothing but 4, as well as the size of 3 will also be 4. Okay. Now after this, you have to check that size of 1 is 4. So 1 is having a group of 4 friends. Excluding itself, the group will be 3, and excluding 3 also, the group will be 3, right? Excluding 1 and 3, the total number of other elements would be 3. So now is 3 greater than the maximum? Yes. So I'll update this with the maximum now, and maximum will get updated to 3 now, and then I'll push the maximum here. Okay. Then after this, what happens is later on I'll check, are 2 and 4 in the same component? Yes, 2 and 4 are in the same component. So I'll not do any union here, and I'll just push my maximum as 3 only. Right. So you can see 1 1 3 3 will be the answer. Is that clear? So I guess 1 1 3 3 was the answer. So is this part clear? Please write yes in the chat. Thanks a lot. So yeah, is this part clear to everyone, guys? You can tell me, and please hit the like button if you're clear so far. Everyone is clear? Okay. +1 in the chat so far if you're clear, and then I'll proceed further, guys. Okay, so yeah, what you need to do here is you will basically say that in this particular scenario, you will say that if it is not, if the parents are not the same, then you will say that the size of P will get updated, plus is equal to the size of Q. Okay, and then the size of Q will get updated to this particular updated value, size of Q that you have already updated, right? And then you need to do the union of the P as well as the Q. Okay, because the union otherwise would be required. And also one more thing, the maximum value you need to update. So what you will do here is mx is equal to max of the maximum value so far, comma what, comma the size of this thing, the size of P -1. Okay, like P -1 or Q -1, whatever you want to take, both will be the same now at that step. And then you will do the union, and once you have done the union, then I guess we can always push back the maximum after every step. Maximum group size excluding the element. Okay, and then at the end, I guess we can return the answer. I might have done some compilation mistakes because the code is long and I've explained a lot. For this Java, this, no worries. Yeah, let me try and compile this. Maybe there might be a lot of compilation mistakes. I hope that there are very less mistakes in terms of compilation. It says that DSU int max is private. So what is the issue here? Like, should I name this class as public or something? Int n. So DSU is private. Like, I think I need to make this as public. By default, it is private, I guess, or something. Then let's say I'll make this as public also, but it is not required. So let me just check now if it works. Okay, it says that union cannot be used directly. So I guess for union, I need to do d dot union. No? And I guess union is a keyword. So that is why I need to do join. I can write join instead of union because union is actually a keyword. So I can write join here. Okay. Let's see. It does work fine on the samples. You can see we are getting the output as 1133. Hopefully it should get accepted. Let's see. Okay, it gives me a wrong answer here. Why does it give me a wrong answer now? Is there any mistake that I have committed here? Your code doesn't work for one. Its correct output is this much. So is there any issue with, okay, yeah, I should update this to P. Yeah, sorry, I forgot to update it correctly. Now it will work. Size of Q will be equal to P, the updated size of P. Your code's output is this, whereas the actual output is this. Is there any mistake that I have made somewhere? So what, like anyone can identify line number 142. Yeah, now I have fixed this also. Still I'm getting this error. So is there any other mistake that I have made here, guys? Is there any other mistake that I have made here? Mm, Sorry, this is my last desperate attempt. Okay, you have shared the whole code in the chat, but I cannot copy it from here. Yes. So the issue is that we are having this thing. So we are having the, like, what is the issue now? Anyone can identify that? Let's check. So what I have done here is, like, firstly I have declared the size as 10. Then what I've done is I have answer also. Then I have this guy also, that is fine. I have declared an object. I have the answer vector. Then I'm iterating also through all the pairs, and I0 would indicate the P, I1 will indicate the Q, that is the first and the second element. And if their ultimate parent, suppose if I find this and this, if their ultimate parent is not the same, then what I'm going to do is I'll say that the size of P will be plus equal to the size of Q. That is fine. But I guess what I should have done is, no. Actually, it will be equal to the ultimate parent. No, sorry. It should be equal to the ultimate parent. So I should do this thing. The sizes should be updated with respect to the ultimate parent. Okay. So this will be equal to Q, because ultimate parent will represent the size. Now, a guy cannot represent the size properly. Like, you have to represent the size by using the ultimate parent. So that is one mistake that I have done. Right. Whatever is the ultimate parent, according to that, the size should be considered. Okay. So this is one piece of mistake that I made. I think now it's fine, right? Let's run on it. Basically, if P and Q are there, so whatever is the ultimate parent, that is going to return that is going to show me the ultimate size. So that is why I'm doing for P, the size of its component can be represented by the ultimate parent. That is what I'm trying to say. Okay. So yeah, now let's see. It works. So small mistake was there. I hope you can understand this. What was the mistake? I'll tell you. Suppose that you had got one. Okay, then you had got three. Then you had two, and then you had got let's say three. Okay. Now suppose you had got four also, guys. Okay. Suppose you had this particular thing. So the issue was, like, see, this is a big learning for you. The issue was that if I'll see the size of four now, so 4 cannot tell me the size. Actually, for the size I have to actually for like I have to take the size of the find four. Why? Because of the simple fact that for find 4 I'll get 1, and what will be the size of 1? The size of 1 will tell me 4, right? That is total, there are 4 elements. So that is why it is important to take the size like this. Does this make sense? Please write clear in the chat. Is everyone clear with this part? What was the mistake that I was making here? Does that make sense while connecting? Yes or no, guys? Does this make sense what I have done here while merging? Because when you are merging the sizes, no, so the ultimate parent will always tell you the size of that whole friendship component. Make sense? At least write clear in the chat, then we'll move on to the last problem also. It's working, right? Please write clear in the chat so far. If you're clear, then we'll ultimately move on to the last problem also. Okay. +1 in the chat so far. Everyone is clear. Then we'll move on to the last problem, guys. Quickly tell me. Don't worry, I'll try to wrap up within the next 20 minutes or 25 minutes. +1 in the chat, guys, and please hit the like button. Then we'll proceed further. Okay. Can we proceed further? Next, you need to write next in the chat. Can we get 90 likes now? Let's see. Can we get 90 likes, and then we'll proceed. Why you added 10? Why we added 10? This person is asking. Basically, whenever you declare, na, so you don't want to have a runtime error. Okay, because suppose if I declare a DSU of exact size, and if by accident, can you repeat the last one? Last one, I will repeat which part, Shyam. You are talking about this part. Basically, what I'm saying is, now, suppose when I was merging, so suppose that if you have two different components, I'll tell you. Suppose that if you had A, right, then you had B here, okay, then you had C here, and then you had D here, suppose, right? Now suppose you had what, like suppose you had X here, then you had Y here, and then you had Z here. Suppose that you are going to do what, you are going to join D and Z. Okay, so can D tell me the ultimate size? No, D cannot tell me the size. For getting the size, I need to do what, I need to find the like for getting the size, I need to find the parent of D, and the parent of D will come out to be what, the parent of D will come out to be 8. So size of sorry, parent of D will come out to be A. So in this case, the size will be 4 here, basically, right? And then when you will see here also, so the size of suppose that if you see here size of Z, so basically size of Z is something that cannot directly tell us about the answer. So we need to find the parent of Z here. Sorry, I'll just merge it. So yeah, you need to find the parent of Z here, so that you can get the size of X, and the size of X will be indicating 3. And then you will say that this, the whole component, the size of now you can say that the size of A plus is equal to size of X. So the size of A will now get updated to what? Size of A will now get updated to nothing but 7. Okay, so here the size of A will get updated to nothing but 7. Okay, and then the size of X will get updated to what, it will get updated to 7 also. So basically after that you will do size of X plus X is equal to whatever size of A has been updated to, right? So something like this here. Clear, guys? So yeah, now you have understood this. I have logical error in my code, but implementation it's perfectly okay. Okay, no problem. So yeah, did I share this code link or not? I guess I did, but I'll just do it again. Okay, then we'll move on to the last problem. Please write +4. Then we'll move on to the last problem, and let's see if we can increase the like count or not. I am putting in a lot of effort, so I hope that you do understand this. And you can comment what is the temperature in your respective cities right now. Can we move on to the last problem, guys, now? Can we move on to the last problem now? Did you learn DSU data structure after this? Like, at least you have a better idea now? I could have written the code directly, assuming that you knew it, but I still gave a better idea. 24. 24 is what? Okay. So yeah, now coming to this problem, jump problem X. So basically the name of this problem is what? Jump problem X. So let me write this now. Yeah. So jump problem X. Yes. So let's have a quick reading of this problem. It says that Geek comes with a special jump game problem. Okay, jump problem. Now he is given an array of n integers, and he is starting on the index 1. So index 1, I guess, means from the very first element of the array, and his goal is to reach the last index. So basically you can say ultimately what they are saying is that you have got an array. Okay, you will be given an array. You are going to start from where? You're going to start from the 0th index of the array, and you have to end at the n minus 1th index according to zero based indexing. Okay, suppose if in a zero based index array, you start from the 0th index, and you have to end, the end point will be nothing but n minus 1 here. So you have to start from here and end here, and you have to follow certain conditions, right? What you can do is, if suppose that you are at a particular place I, okay, then you can jump to J. When you can jump from I to J, there are several conditions in which you can jump from I to J. Understand this, these three conditions that are given, right? So if he wants to jump from I to J, then any of the three conditions should satisfy, right? So if you want to jump from I to J, so either of the three conditions you should satisfy. So suppose that you want to jump from I to J, then one of the conditions is that the J value one of the conditions is that the j value should be equal to I plus 1. Okay, so suppose if you want to jump, then if the j is just adjacent, okay, if suppose that the I value is 3 and the j value is 4, so if this is just the next index, then you can jump. Is that clear? Please write clear in the chat. Please write clear in the chat. Is this part clear? If you are jumping on to the next index right away, then this can be considered. Does that make sense, guys? If you're jumping onto the, like if you're jumping on right to the next index, then does that make sense? Clear. Okay, money Kanta says clear. Okay, right. So yeah, if you directly can jump onto the next index, then it will work. Or what you can do is, there are two other conditions that you need, that you might satisfy. So other condition is that if you want to jump from I to j, so other condition is that suppose you have this array, okay, and you are at this ith place and you are at this jth place, right? Now what will happen here is that suppose if you want to jump from I to j, then all the elements in between will be from which index to which index? From I plus 1th index till I plus what? I plus sorry, till j minus 1th index, right? All the elements in between will be these elements till this elements. If all these elements, suppose that you will talk about a array of I plus 1, right, comma array of I plus 2 up till where? Up till this point, array of I plus 2 up till array of j minus 1. So if what happens, if the maximum of this thing, okay, if the maximum of this thing, these intermediate elements, if the maximum of the intermediate elements, okay, if it is less than equal to the minimum of the ith element and the jth element, okay, if the minimum of I and j, if the minimum of the ith element and the jth element, if it is greater equal to, if the minimum of a of I comma a of j, if it is greater equal to the maximum value in between, maximum value from I plus 1th index till j minus 1th index, okay, then you can jump from I to j. Is that clear? Please write yes in the chat. Is that clear to everyone? Please write yes. Does that make sense? Does that make sense, guys? Right? Does that make sense? That if you want to jump from I to j, then the condition, then you need to satisfy a condition that in between that strip from I plus 1 to j minus 1, all the elements maximum should be less than equal to the minimum of ij. Right, clear. So this is one criteria. Now how can you find this thing, right? Because for if you will see now, so you ultimately you have to find, like, see, if you will try to find, if for every index you will try to iterate, so that is going to take a lot of time. So for one time, if you are going to iterate, so that is going to take order of n time. So if you're going to iterate n times, suppose, then it is going to take n square time, at least it would take n square time. So it is going to be complex in nature. It is going to be square complexity in nature by default. Are you getting my point? If for one particular I and j pair, if you're going to iterate in between and find the maximum value of the middle part, so that is going to take a lot of time for you, right? That is going to take a lot of time, which is something that you don't want, to do. Because for one step, if you will take order of n time, so for n you will take order of n square, which is very very high. Is that clear? Please write yes in the chat. So for this, what you can do is you can find the you can use the concept of stacks here. Okay, you can use the concept of stack, because ultimately you have to find, you see, you want to get the idea from the right side. So basically what you can do is you can find the maximum index of the maximum elements on the right and the minimum on the right. So you can find next greater on the right, next smaller on the right. Does this make sense? Please write yes or no, guys. Is that clear to everyone or not? Is that clear? Please tell me, guys. Does this make sense? Just quickly let me know. Okay, so that is why you need to use a stack here. Right, now coming forward to another part, that is after this is done, suppose that once you have calculated, once you have used the stack process. So is everyone clear why I need to use a stack? Because I will use a stack simply because of the reason. Please take example. See, if I will take example, that will take a lot of time, Daya Shankar. So I'm assuming, see, if you have for this also there is a prerequisite. Okay, prerequisite, like for the previous problem you had the prerequisite of DSU. So for this problem you have a prerequisite, that is you should know the next greater element concept. Okay, next greater element and next smaller element, something like this. You should know these concepts, and then then you will get the intuition. If you know these questions, right, then you will get the intuition that why we are using stack. And even when you use stack, even after that, you have to find the shortest. You have to find the shortest path, no, the smallest path. Like you have to find the minimum steps. So if you want to find the minimum steps, even after that, then you still need to use a queue data structure, because you need to apply the BFS approach. So you need to either use a queue, or you can use a DQ as well. Okay. So either you can use a queue data structure, or you can use a DQ data structure, because if you want to find the minimum steps, so which algorithm can help you? BFS can help you, because BFS will help you to find the shortest path in unweighted graph. Right, so this graph, this will be unweighted, so that is why you'll use BFS also. So this question is basically using stack concept as well as the Q and the DQ concept for finding. Once you have found the minimum, then it will help you to satisfy the then it will help you to identify the max and the min conditions very easily. And once you are able to use the stack, so condition 2 and condition 3 can be checked in constant times, right? And once you check them, then after that, your job is to find the minimum steps. So if you want to do something in minimum steps, so it's just like using shortest path, right? So shortest path where the weight is where the graph is unweighted. So like every going from a particular, like taking any jump, if you take a jump of 3, 4, 5, 7, anything, so that will be considered as one jump. So that is nothing but every path will have the cost as one. So that is nothing but BFS, right? So I hope you are getting this. And in this, you have to find the shortest path or shortest weight path of length 1, right? So I hope this makes sense. Is that clear? Please write +1 in the chat. For those who are here till this point, does this make sense for everyone so far? Yes or no? Okay, tell me, and then we'll just code it up. Okay, please write +1 in the chat, guys, so far, if you're clear. I'm just waiting for 1 minute, and then we'll start coding it up. Can we start? Okay. Let us now finish this question also. Okay. So what I can do is I can say that I need to store inside a vector, I need to store the index of the next greater. So vector int, let's say I will name a vector as right greater. So right greater, yeah. And let's say n comma n, because initially I'll mark the right greater index as n only, then I'll keep on updating. Okay. And then vector int, basically I'm initializing for every element, I'm initializing with the maximum value, right? But later on it will get initialized to the lower values as we keep on moving in it. Okay, so right is smaller also, we need to write, or write lesser. And here what I will do is n comma n. Okay, then after this I need to declare a stack, let's say st, and then int st, sorry. Yes, I will declare a stack here. Now once I've declared this stack, so what I need to do is I need to iterate. So I starts from 0, I is lesser than the size, then I'll do an I plus plus. Then once this is done, so what I will do is I'll check that if the stack dot empty, suppose if the stack dot empty is equal to false. So I'm assuming that you will learn about the next greater element or the next smaller element, just in case if you don't know. Please write okay in the chat. Is that fine? You have to learn this. I cannot teach these problems, otherwise this will take 3 or 4 hours. So you need to know the next greater element, next smaller element in concepts, so you can learn about them, right? NSG, like I'll just show you here. Next smaller element on right GFG. Okay, so next smaller element on right, you have this thing. So yeah, next smaller element, like these problems are there, you can use them if you want, right? And then next greater element on right also, I need to write this. Next greater element for every element in the array, this kind of thing. So yeah, you can learn about these things using stack data structure if you want. So actually this question uses a lot of concepts here. Okay, now what will happen here is, suppose that if the stack is empty, right? If it is If the stack, if suppose what I need to do, since I want to check with the top if the stack dot empty is false, suppose, right? And then at the same time, suppose that if the stack is not empty, and the top index at the top of the stack, if it is having element lesser than AR of I, so I'm assuming that you know this concept already. So then what I need to do is I need to update my right greater as what? Then I'll update my right greater as st top, because at this index I'll directly update I. Okay, and then what I need to do is I need to pop this guy out. Otherwise, I can simply push inside the stack. So I'll push the ith index. Okay. So let me just think. What I'm doing is, if I'm finding the right greater. So suppose that if what I have is if the stmt is false, and at the same time error of st dot top is lesser than error of I, then I need to update my right greater is this, and then this thing is this. Then I'll push the ith one. Okay. Now after this, suppose that I will use stack int st2 also, right? Now I'll do it for the right smaller also. So I'll just change the condition a bit. I guess that will work. So let me just copy the whole code again, and I'll paste it here, and then I'll change a few conditions here and there. So if suppose that since I am looking for the greater guy, lesser guy, so I have to change the symbol to this, and then I'll write right lesser here. LESSER, right lesser will be updated. Since I might be doing it multiple times, so I should use a while loop here instead of if. Okay. So yes, like after this, what I'll check is if the stack is empty and the top element of this is greater, then I'll update this to I, then I'll pop this out and I'll do this. Okay, this is fine. Then after this, so this much part is clear. It's tough. It's DP problem. It's not DP. It's I used. I'm planning to use stack plus DQ here. Yeah, you can use not of stack dot empty, but I don't want to write that kind of condition. No? I just want to write equal to false. That works also. No? Right. So then I will do what? Then I will declare a DQ of pair, because here I want to store the starting point. Like I want to store the current cell that I'm at as well as the number of steps that I have taken. So initially what I need to push in my queue. So initially what I can say is that I will simply push the pair as 0 comma 0, because my starting point is 0 and the number of steps that I have taken so far is also 0. Also one more thing, I need to have a visited array also, because if I have visited a cell already, then I don't want to visit it again. Okay. So I will say that all the n cells that are there initially I'll mark it as 0. Okay, then what I need to do is I'll say that while uh, then what I need to do is, let's say you have this thing. Okay, now what you will do is, once you have this, right, so you will say that while the dq dot size is greater than 0, so if it is still having some elements, then you will try to run it, and then you will get the pairs of pair of int comma int. The p pair will be equal, will be equal to, let's say, dq dot top, or can I pop it directly? I guess I can do dq dot front directly, right? And then you can use a q also, I think, instead of this. Okay, so then you can pop it out, and once I have popped this guy out, then what should I do? Like I will pop out the front now, because I'm using dq here. So yeah, the this guy will get popped out, the front guy, and then I can say that the current index that I'm at will be what? The current index that I'm at will be nothing but p dot first will be storing the index, right, and the second will be storing the number of steps. So int the number of steps that I have taken, or the number of jumps, you can say, right? The number of jumps that I have taken so far will be nothing but p dot second. Okay. Now after this, if I am at a particular cell, so what can I say? If suppose that the index that I am currently at, if it is equal to the last index, then whatever number of steps I have taken so far, whatever number of jumps that I have taken so far, I'll just return that jump. Okay. If this is the condition. Otherwise I'll say that if this is not the case, then I will say that let us try and make our temp as index plus 1, and let us try and explore that scenario for the next index. So what I will do is I'll do plus 1 here, and then right after this, what I will do is I'll check. What I'll check is that if the error of temp, okay, so I'll check that if the error of temp is greater than the error of index. So basically what I'm checking is, if what I'm checking is that if it is lesser compared to the temp. Okay, if it is lesser, then I should do what? Then I should Okay, so I guess I got dropped out. Where did I get dropped out, guys? I'll have to check. Shit. I guess I got GFG timeout. I don't know what happened automatically. Let me check. Did it happen for a long time or it just happened right now? For 1 minute only? For past 1 minute or it happened throughout? Let me check the spot. I just for 1 minute, no? Okay. So it happened only for 1 minute, I guess, right? For a few seconds. Okay, then it's fine. I checked it at the right time. Otherwise, it would have been very difficult to revise again. Okay. So no worries. Yeah. So temp is equal to index plus one is what I am planning to do. IDX plus one. Okay. Now what I will say here is that if the element at this temp, okay, suppose if it is greater, then what I will do is I will say if this element is suppose greater. So if this element is greater, then I will check. What I should check is that if the temp index is not equal to end, suppose. So if I don't suppose that if I don't want to reach the end, and at the same time I want to check that if these temp elements, if they are greater than my ith index. Okay. So if it is greater than my starting index I and dx, what have I written here? I and dx. No? Yeah. So if it is greater than this, then what I will do is I'll always keep on doing this thing that inside the dq, I'll always push what? I'll always inside my dq, I'll always push back. So I need to write push back here also. Right. So yeah, I'll always push back what inside my dq or inside my q also I can push. So inside my q, if this is the scenario, right? So then you can say that if the current index that I am at, right, if it is like if the current index that I was at, right, if it is having if the next index of it, that is temp, if it is having a higher value, then what I will do is I'll store it inside, I'll store the pairs inside the dq. Now what kind of pair? I'll store the temp pair with this thing, with steps one plus one. Okay, like basically I'll say that if I have a guy that is like if I keep on getting the increasing path, right? Are you getting my point? Like what I'm trying to say is that suppose you had something of this kind. Like what should I say? Suppose that your index, like this was the index that you were at in the inside the whole array, right? And let's say this is the temp index now, and yeah, suppose this is the temp index. Now if you had the element suppose as 7 here, right, and now here you have the element as 10. So since this guy is greater, no, so I'll say that what like I'll say that now I'll push this index and I'll say that I'll take one step to move here. Okay. And then again, suppose that if this guy is suppose what 17, right? So if this guy is also greater, so then I'll say that from here to here, in order to move, if I had taken, so suppose two steps to move till 7, then I'll take one more step to move till here. Okay, then suppose it if it was 20, so from like again it is increasing, so I'll say that now from here to here I can move in one step. So whatever steps I had taken till this point, right, now I can say that plus one step I will take from here, because if it is in increasing order, so you can see like basically what will happen is the maximum of the between range, I hope you understand, the maximum of the between range is 17. It is less than equal to this thing. No, I need to check this just a second. What am I saying here? There are two conditions now, like the minimum of this range should be greater than this thing. The condition 3 is there. Okay, so yeah, in this particular case I will store this and I will use the right maximum. So what, like I will find the next greater index for the, like I'll update my temp, instead of updating it to the index, I'll update it to the next lesser element. So right underscore lesser, let's say, of temp. So what I'm basically trying to say here is that if I am at a particular temp, right? If I am at a particular temp, so suppose that if I am at a particular element, let's simplify this. Suppose that if I'm at a particular ith index, so I'm trying to make both the conditions true. So if I'm at this temp index, right? Now for this particular temp element that I am at, if this particular temp element is greater, okay. So basically, if the temp element that I have that is on the right side of my current index, right? That let's say IDX, if it is greater than element at this index, then what I'm trying to do is I'm trying to say that we will try to see this peak, right? So this peak will always be there. Like, so I am saying that if this element is there, so suppose that these elements are increasing, right? Suppose that this element was, let's say, 8, right? And now these elements are, suppose these are 9, 10, 11, 12, right? So now I am trying to find the index of the next smaller element after this. So after this element, whatever is the index of the next smaller element, right? If this is my temp, so if this is increasing on order, suppose that in between what you have is, understand this thing very clearly, guys. This is very important, because if you have got, suppose that you have got 8, then you have got 9, then you have got 10, okay, then you have got 11, then you have got, suppose, something like, what can I say? Suppose that you have got something like, let's say, what you have is, let's say, you have got 8 here, so suppose 9 here, okay. Then what you are trying to do is, you are trying to find the index. Let's say you will try to find this particular index, that is for this particular element. You are going to get the index of the next smaller element on the right. So let's say you get what, something like, next smaller for 9. So let's say in between what you have got is, let's say some, like, there are some elements, then you find this. So basically now when you find this element, so this will be considered as a jth index. That is what you are trying to do. Does this make sense, guys? So for any element, like, so that you can consider the minimum of the two. So whenever you are at a ith element, right, then in between, after that, the temp span that is there, you will consider it. And in that whole span that you have, uh, in that whole span that you are having, right, after that you will find the index of the next lesser element. So does that make sense? Next lesser element on the right, index of the next lesser element on the right. Does that make sense now, what we are trying to do here? So that we can find a dip, so basically what will happen, the ith element is there, then in between you have the greater range, and then the lesser element. So does this make sense, guys? Yes or no, please tell me. Right, I hope it makes sense. uh yes or no, you guys can tell me. Okay, so yeah, let's finish it up quickly. So what I will do is, if the temp is, let's say, not equal to n, then what I will do here is, in my dq I'll push back what, in my dq I will push back the temp with the steps as, steps plus 1, right? If it is not equal to the end, otherwise, suppose that if it is equal to the end, so if it is equal to the end, then I can say that I need to check for the next greater on the right, okay. Because if it reaches the end, if I'm not able to find the dip, then I have to find the other, for the other condition. So then I need to write that while the temp is not equal to n, and at the same time the error of temp is what, it is less than the index. So I need to find for the other condition that is there. So for this index, I'll say that if it is less than this index, right, then in this particular scenario, what I need is, I need to push inside my DQ. What I will push back is this particular temp along with the number of steps as plus 1. So steps I have taken so far plus 1. Okay. Then I will do what? Temp is equal to right underscore smaller, and then for this temp, so we'll update it to the next smaller index of the next smaller element on the right side. Okay, once I have done this, then I'll check that if the temp is not equal to n after I end this loop, then what I need to do is, inside this queue again I will make this pair and push it. So let me just push it if it was not pushed. Okay, then at the very end, after this loop will be over, suppose, so I need to return -1 also. Let me see how many mistakes I have done. N was not declared. Okay, n should be small. Steps, okay, steps, where is steps? st2 is what I should write here. st2 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 st2, okay. Then we have got steps. Okay, I should write steps here only. Let's try and run it again and see what happens. N was not declared. Okay, so let's write it as less than n. Again, n was not declared. Jumps was not declared, but I have already done it now. Okay, return the steps. I should write steps here. Okay, then after this, I start from zero, line number 53. Okay, now it should work fine, I think. STEPS, line number 93. Let's try and run it now and see. Write smaller was write lesser is what I need to write here. Sorry. Let's run it now and see what is going to happen. My output is -1, whereas they expected 3. Okay. So something is going wrong with my code. Let me just see what is the issue. Yes, I guess once I have visited like a cell, I have not marked the cell as visited again. So I should do one thing, that once I have taken the index, then I'll say that the visited of this index will be marked as 1. Now let me check. I just forgot to mark it as visited. No? And maybe initially I should mark 0 as visited. No, still it is not working properly. So there is some issue. Let me just check this. So what I've done here is I have the right loop ulte honge. Loop ulte honge? I don't think so. Dipanshu, like I guess we can find it like this only. So you have the right greater, then this, then this. Okay. Initially you have initialized every index to maximum because that is what is required. Then you have declared the stack. Okay. Then we are iterating. If the stack is not empty and the element at the top of the stack is lesser than the ith element, then write lesser for this top guy should be updated to the ith index, and then we should pop out from the stack. And then after that I'm inserting the ith element. That is fine. Then I have declared a second stack, and once I have declared the second stack, so what should be done here? I still need to think about this. Like, what should I do? Maybe there's some mistake here because whatever is the scenario for the stack, I have to take care of that. So let's say what I will do is if I do something like this, st2 is equal to this thing. Let's run it now. Okay, so suppose if I declare a stack like this, and then I will run my process on the normal stack. So let's say if I don't even use this, okay, and what I will do is I'll do it on this stack only because this can work, I guess. Right. Still it is not working for some reason. Okay, no problem. Then you have declared the queue, so this is fine. This is also fine. Then this is also fine. Then if the DQ size is greater than 0, then you take this guy out and you do what? You pop it from the front. Then I take the index also. Then I take the second part also as a step. Then if like okay, then what I should have done is now, like if the visited of this thing index is equal to 1, suppose if it is already visited, then I should have continued. Now I guess I was missing this part. Let's try and see now it works or not. Okay, still it is not working, so I need to check further also. Otherwise, if the index is reaching the last place, then you do this, and then you do this. If suppose that the ith element is this thing, else like I guess I need to take this thing out of here. There's a bracket issue. Now else is here. Let's try and run it now. Okay, now it is working fine, guys. So yeah, sorry. Basically, it was a if else issue. I had after this if I had written else, but basically after this if I had to write the else. No, after the outside if I had to write the else. So that was one mistake that I had made. Sorry for that. Yes, now it should work. It is not working correctly. So I guess still we are making some mistake somewhere. So let's try and debug further. So what I am doing here is I am saying that the index, like while the temp is not equal to n and the temp is greater than index, then you will do this, then you will do this, then you will do this, then you will do this. Okay, then you will do this. Right lesser. I'm writing right lesser at both the places. That is wrong. Now I should write here right greater actually. That is the mistake. Okay. Because firstly we'll find the right lesser, but next time when we are running the other loop, then we want to find the right greater. That is when you stop. Okay, because if you're finding a lesser dip, then you want to find the greater part. Okay, still it is not working fine for some reason. So should I declare another stack or something? There is some issue with my code somewhere. Let me check if by declaring another stack it will work or not. So st2, then I'll declare st2 here, then I'll declare st2 here, st2 here as well. Let's run it. Still some irregular there. Okay. Works fine, I think, but let's submit. If it is because of stack, it will work. Otherwise, it might be an issue. There might be an issue in the logic. Okay, yeah. So basically, I was using the same stack now, so that is why. Because the previous stack might have not been empty now. That's why. So I had changed actually this logic, but I was using a second stack already. But since it was not working, so I had manipulated. But I have just used a second stack for finding the next greater on the right side, index of the next greater on the right. So I hope that you are clear, guys. Basically, with this problem. So I'll just share this code. Are you able to understand this, guys? Okay, so let me share this code. Now tell me, did you enjoy this session? Right. If you will see, if I'll summarize. So first problem was what? Question, like if I'll summarize for all the questions now, no? So we had a couple of things uh, in the pipeline. Firstly, we had sorting plus two pointer, the first question. Then second question was kind of an observation based question. Then the third one was basically based on the DSU concept, and then fourth one was based on what? Fourth one was based on stacks, that is the next greater element, plus the BFS approach, right, for finding the shortest one. Clear, guys? Any questions for you? Do you have any questions, or should we wrap up now? Should I wrap up now? Can you go through the last question one time, please? Yes, wait, but actually, I guess you can watch the recording because already it is so long, 2 hours, 20 minutes. It's a lot. So I hope that you enjoyed. Just give me a plus one before we end this. I hope that you have enjoyed, guys. Just in case if you have any doubt, now you can comment in the chat and I'll clear your doubts. Okay. Just let me know in the chat, guys. I hope that you enjoyed it. Thanks a lot for joining, and just give me an acknowledgement for the last time, and we'll end this session now. Okay. So yes, thank you guys, and bye. Take care. All the very best.